Okay, pre-calc, this one is kind of a long lesson, so I've written a lot of it out already. It doesn't need to take a long time. I might not do every single problem. It's not really anything new. It's just looking at the difference between arithmetic and geometric and deciding which one to use. Okay, I wrote these up here. If you can see them, this is the arithmetic, this is the geometric. The directions are determine whether it's arithmetic, geometric, or neither. If it is arithmetic or geometric, then write an explicit formula to find the nth term and find A7. Okay, so we have a lot of things to do. First thing, when you're looking at a sequence, if it's going up very quickly or going down very quickly, then I would check geometric first. If it's going back and forth between positive and negative, then it has to be a geometric or neither. It cannot be arithmetic. So I took negative 42 divided by 14. I got negative 3. 126 divided by negative 42, negative 3. And then the last one, and I got negative 3. So this is geometric. And our AN is our first term times R to the n minus 1. Pretty easy, right? And then to find A7, we just substitute 7 in for n. So we're going to take negative 3 to the 6th times 14, and you should get this. All right, number 2 goes back and forth, positive and negative, so it can't be arithmetic. So I put negative 1 divided by 1, and I get negative 1. 2 divided by negative 1, and I get negative 2. That tells me right there that it is not geometric because these are different. So it's neither, because it can't be arithmetic going back and forth. Right, number 3, if you look at it, it's going down this time, but it's going much slower than, like, say, number 1. So I'm going to try to see if it's arithmetic. So I take 44 minus 53, negative 9. 35 minus 44, negative 9. 26 minus 35, negative 9. It's arithmetic. So I'm going to use this. I'm going to say D times n minus 1 plus A1. And I'm going to simplify this. Don't leave it like this. Simplify so that I get negative 9n plus 62 when I distribute that negative 9. And A7, if I substitute a 7 in for 9, I'll have negative 9 times 7 plus 62. I should get negative 1. All right, number 4. Again, it looks like it's arithmetic because the bottoms are all staying the same as 4s, but look at the tops are only going by negative 2s. So when I do this, I find that I'm adding a half each time. So this is arithmetic, and D is a half. And if I simplify this, I should n minus 17/4. And substituting a 7 in for n, so I'd have 7 halves minus 17/4. I should get negative 3/4 for A7. Number 5, I tried doing subtraction. 2/9 minus 1/10, 3/8 minus 2/9. You do not get the same thing. Same with the other. This is a neither. And you can try these. I mean, I'm doing them by hand here. You can do it on your calculator. And for number 6, again, it's going down very quickly. So I checked geometric, and it's geometric with R equal to a 4th. And so our AN is A1 times R to the n minus 1. So A7, I would take 1/4 to the 6th times 320, and that is 5/64. All right, let's look at number 7. Number 7 is arithmetic. I've been putting ART. It should be arithmetic with D equal to 26. So AN equals oh no, not A1, equals D times N minus 1 plus A1. And simplifying this, you should get 26N minus 171. And to find A7, just put a 7 in for N, and you should get 11. And the last one, number 8, last one of this kind is geometric, and R equals -5/3. So AN is the first term times -5/3 to the N minus 1. Geometric is a lot easier. You don't have to simplify once you substitute anything in. And substituting a 7 in for the N, you should get -100, this. All right, that is the difference between arithmetic and geometric sequences. Now we're doing series. The directions here just say find the indicated sum. It doesn't tell you if it's arithmetic or geometric, so you have to figure it out and then use the right equation. Remember, this is arithmetic. That one is arithmetic, the first term plus the last term divided by 2 times N. And geometric is A1 times 1 minus R to the N over 1 minus R. Remember that? Okay, so this is geometric. This is arithmetic. So that's the first thing you got to decide is which it is. Number 9. What do you think number 9 is? Just looking at it, I would try arithmetic, and it is, because 25 divided by 18 is not going to be the same as 32 divided by 25. So this is arithmetic. So we're going to use this. We need N, which is 19, and we need the first term, which is 18, and we need the last term, which is A19. So we're going to have to use our formula. We need to find what D is. Looking at that, D is 7. So we're going to say 7 times 19 minus 1 plus 18 equals 144. Let's see. Let me make sure I'm doing that right. 7 times 18 plus 18 equals 144. Yes, that's our last term. So we can substitute it all in, and we can say S19 equals 19 times the first term plus the last term divided by 2, and that is 1539. Okay, number 10 happens to be geometric. Goes back and forth between positive and negative. So A1 is 3, R is -5, and N is 7. So we're going to use this geometric equation, and we're going to say 3 times 1 minus -5 to the 7th over 1 minus -5. And doing all of that, you should get this. All right, let's look at number 11. Number 11 is arithmetic. So we need A1, and we need N, and we need AN, which is A11. And we're going to find that by using our equation. And so we have to know what D is. So is -5, right? Yep. So we're going to say -5 times 11 minus 1 plus -9, and you're going to have -59. So then we can find S11 as this, and you should get -374. Number 12 is geometric. So we have a 1, which is -1/2. We have R, which is +1/2. And we have N, which is 8. Okay, geometric's a little bit easier because we don't have to find that last term. So we're going to say -1/2 times 1 minus +1/2 to the 8th over 1 minus 1/2. And this equals -255 over 256. Look at that, it almost equals 1. Number 13 is geometric. So we only need the first term. And we need R. And we need N. And if you put that all into your equation, ooh, look at this. 58025 over 1458. All right, number 14 is arithmetic. So we need a 1, which is 12/5, and we need N, which is 13, and we need a 13. So we're going to use our equation, and this is going to be, I'll do it on here. D is, let's see, is 4/3, I think. So let's see if that works. 4/3 times 13 minus 1 plus 12/5. This is going to be 12. 3 goes into 12/4. So this could be 16 plus 12/5. I think I did that wrong. Maybe that's not what D is. No, that's right. One and a third. So let's see. That would be 16 times 5 plus 12 equals 92/5. Oh yeah, that's right, 92/5. So we have S13 equals 13 times 12/5 plus 92/5 over 2. And that equals 676 over 5. All right, that was number 14. Now we're moving on to number 15. It says determine whether the series is arithmetic or geometric, then find the sum if possible. So you can tell just by looking. Okay, number 15 is arithmetic because of it has a subtraction. Look at number 16, that one is geometric. So number 15 is arithmetic, and we need a 1, which is substituting in a 1 for M. So we're going to take 23 minus 6 times 1, and we're going to get 17. And we need the last term, which is 28, where we put a 28 in for N, and we're going to get -145. And N is 28. So we're going to say S28 equals n times the first term plus the last term over 2, and you should get negative 1792. All right, number 16 is geometric. Our first term is negative 5, r is 2, and n is 13. Substituting it all in, you get this, and you should get negative this. All right, 17 is arithmetic, so we need the first term, which we're going to substitute a 1 in for C. And we're going to get negative 5/12. And we need the last term. Oh, I did that wrong because we're not starting at 1. So let me do that over. Putting the first term, we're going to substitute a 5 in for C, because notice that we're starting at 5. And we get negative 5/12. And then we're going to substitute in 34 for C. And you should get 37/4. And our n is going to be 34 minus 5 plus 1, which is going to be 30. So S30 is 30 times this, and you should get 132.5. And 18 is geometric. So again, though, we're not starting at 1, so we have to substitute 3 in for n to find our A1. So we're putting a 3 minus 1, so that's going to be 2, and this equals 5/12, again with the 5/12. And r is negative 1/4, and n is 7 minus 3 plus 1, which is 5. So we have S5 is 5/12 times 1 minus negative 1/4 to the 5th over 1 minus negative 1/4. And this should equal 1025 over 3072. Whew, that was quite a problem. And 19, look at 19 and 20. 19 and 20 go to infinity, and they're geometric. So for 19, r is negative 1/5, which means that it is convergent, and we can use the convergent formula for that. So we can say Sn equals the first term times r. Oh, I did that wrong. Whew. The first term times 1 over 1 minus r. And that should equal negative 35 over 24. And number 20, r is negative 3/2, which the absolute value is greater than 1, so it is divergent, and there is no answer. No sum for that one, because you would just be adding bigger and bigger and bigger numbers, and you're basically going to get to infinity. So that's the end. Oh no, that isn't at the end. Now we have applications. Yay, applications. All right, the applications, sequence applications, these first two. Okay, you first have to decide, is it arithmetic or geometric? Library book that is 1 day late is charged $1.95 fee. Each day thereafter is charged an extra 20 cents. Find the fee for a book that is 35 days late. Okay, that is arithmetic, because we're just adding something each day. The first day is $1.95, and each day we are adding 20 cents. And we're looking for Find a fee for a book that is 35 days late. So we are looking for A35, which is going to be D times 35 minus 1 plus 195. And this is different than I have in my notes, so I better do this. 20 cents times 34 plus $1.95 should be $8.75. All right, number 2, Tucker took an 800 milligram dose of medicine for his headache. The table on the left shows the amount of medicine remaining in his bloodstream after the first 3 hours. Okay, when will it be 50 milligrams? So if you look at that, it is not going down the same each time. It's going down an amount. So if you take 680 divided by 800, you get 0.85. 578 divided by 680, you get 0.85. So this is geometric, and R equals 0.85, and A1 equals 800. And we want to find N when AN equals 50. That's what we're looking for. So we're going to say 50 equals A1 times R to the N minus 1. And we're going to solve this. So we're going to do 50 divided by 800, and you should get 0.0625 equals 0.85 to the N minus 1. Remember that you can do the round the world, and I would say log base 0.85 of 0.0625 equals N minus 1. Go ahead and find this on your calculator and then add 1 to find N. This doesn't turn out to be an even number. We get N equals 18.06, but that's okay because this isn't counting numbers of things, it's counting numbers of hours. And so you can have part of an hour. So at 18.06 hours, he will have 50 milligrams in his system. All right, let's look at the next questions. The next ones are series applications. Okay, stocks at a company were initially issued at $9.80 per share. The value of the shares has increased by 25% each year. They vary about 20 shares the first year they were issued. Find her total investment after 15 years. So is this, for number 3, is this arithmetic or geometric? This is geometric. The percent should tell you that it's geometric. So now we're not looking for an actual amount at a certain year. We're looking at the whole total. Find her total investment. So we're starting with 196. What? Oh, she bought 20 shares at $9.80. So that's 196. So that's how much money to put in the beginning. And our R is 1.25. Because remember that, oh, I don't know what I'm doing here. Okay, we're starting with 196. R is 1.25 because it's going up 25% each year, but we have to have the amount before. And so we're looking for S of 15. This is geometric, so we're going to have 196 times 1 minus 1.25 to the 15th over 1 minus 1.25. And if you do this, you should get 21,498.62. All right, number 4, Evan got a job with a starting salary of $36,000. That should tell you that that's where we're starting. With a $1,500 raise each subsequent year, how many years will it take for his total earnings to reach $1 million? Okay, so this is going to be arithmetic because you're adding something each year. It's not going up by a percent, it's just going up by an amount. I am not going to go through this whole problem. This one you have to use the, I'm going to skip this problem. You have to use the quadratic formula. So I'm not going to do this one. We're going to cross off number 4, and let's look at the mixed applications. Okay, because I crossed off the one like that on your homework. All right, let's look at number 5. A ball is dropped from a tower. The table below shows the height of the ball after each of the 3 bounces. Find the height of the ball after the 12th bounce. Okay, you got to look at that and decide, is it arithmetic or geometric? Well, it can't be arithmetic because you are 45 minus 50 is not the same as 40.5 minus 45. So check and see if it's geometric, and it is. It is geometric, and our R equals 0.9, and our A1 is 50. That's where we're starting, and we're looking for a 12, so that equals 50 times 0.9 to the 12 minus 1, which equals 15.69 feet. All right, not too bad. Number 6, logs are stacked. So there's 40 logs on the bottom and 2 fewer logs than the rows below. So we know A1 is 40. And D, this is arithmetic because it's just, we're adding or subtracting. D is -2. And AN is 8. And we need to find N. Okay, and then if it's set, and then we need to find SN with whatever we find for this N, because we want to know the total number of logs. So we're going to say AN equals D times, no, that was wrong, N minus 1 plus 40. And we're going to solve this, and you're going to get N equals 17. And then we're going to say S17 equals 17 times the first plus the last over 2, and you're going to get 408 logs. All right, that's number 6. Okay, we're almost done. Number 7, when Shaul brought her newborn son John home, he slept just 3 hours the first night. Then he slept an extra 5 minutes from the previous night. So is this going to be arithmetic or geometric? It's going to be arithmetic because he's just adding 5 minutes each time. So we've got A1 equals, I'm going to put it in minutes. So 180 minutes. And D equals 5. He's adding 5 minutes each night. And it says we want to find N when AN equals 480 minutes, which is 8 hours. So we're going to say 480 equals D times N minus 1 plus 180, and go ahead and solve this, and you should get N equals 61 days. Okay, because he added 5 minutes each day. Number 8, Elijah started a new Instagram account and gained 8 new followers in his first week. And then after that, he gained twice as many as he had the previous. This is geometric. Okay, we have A1 equals 8 and R equals 2. It's going up 2 each time. It says how many will we have after 16 weeks? So we need a 16 is 8 times 2 to the 16 minus 1, and that equals 262,144. We're skipping number 9. That's another one of those quadratic. And number 10 is the value of a car. And we want to know, in what year will the value of the car reach $4,000? So we know A1 equals 37,500. This is geometric. R equals 0.84. And we want to find N when AN equals 4,000. So we're going to say 4,000 equals A1 times R to the N minus 1. And we're going to solve this with the whole, we're going to divide 4,000 divided by 37,500 and then take log, and you should get N equals 13.84 years. So if we started in 2012, if you add 13 years to get that, you should get in 2024. Right? And that is the end of this section.